Let's try a different problem of Newton's laws. A force of magnitude 50 Newton is acting at an angle of 30 degrees on a 2 kg object to push the object against the rough horizontal ceiling as shown in the diagram below. The object accelerates to the left at 20 meters per second squared. Ignore air resistance. The coefficient of kinetic friction between the object and the surface of the ceiling is unknown. So we're going to skip 2.1. That says state Newton's second law of motion in weights. We'll go straight to 2.2. Draw a labeled free body diagram indicating all the forces acting on the object while in motion. So first, what we must know is the definition of a normal force, because that is our problem. Normal force is always perpendicular to the surface. It means that our normal force now must face down. So 2.2, so we're going to draw the dot. The dot will represent the object. So now we're going to show weight. Weight is always downwards. And then after weight, we have normal force perpendicular to the surface. Normal force going down. And then after that, frictional force always oppose the motion of an object. So since the object is going to the right, is going to the left, it means our frictional force will go to the right. And then the force is acting at an angle. So that is our force F, acting at an angle. So since it's 4 marks, that's why we're 4 forces. So those marks will be distributed in that way. So 4 marks, 4 forces, just like that. And then 2.3. 2.3, it says calculate the magnitude of the normal force acting on the object. So to calculate the normal force, as long as the force is acting at an angle, normal force, or before we calculate the normal force, we must take the components of that force. So it means now we're going to take the components of that force. We're going to redraw the free body diagram. So we'll redraw the free body diagram here. This is 2.3.1. So the free body diagram will be like this. So weight, normal force, and then frictional force. So for that force, we're going to take the components. It means that now we're going to have Fy going up, and then Fx will go to the left. That is the direction of the motion. So we have Fx as the horizontal component. So now, to calculate the normal force, how many forces are going down? We have normal force and the weight. So it means that now we have normal force plus weight. We're adding because they're in the same direction. And then it's equals to the force that is going up, that is Fy. So we're going to take weight to the other side, and then we have Fy minus weight. So here, what is Fy? Fy is F sine theta. That is a vertical component, minus for weight is mg. So F sine theta, we have 50. That is the given force, and then the angle, they said is 30 degrees, and then minus the mass of the object is 2, then multiply by 9.8. So from here, the calculator is going to give us 5.4 Newton. That is our normal force. And then from there, the last question, it says calculate the magnitude of the coefficient of kinetic friction. So to calculate the coefficient of kinetic friction, you need the normal force, you need the frictional force, we need everything. So Now, what do we have here? We have the forces that are acting parallel to the surface. That is the frictional force and the horizontal force, or the horizontal component of that force. So 2.3.2, we're going to have F net is equals to MA. So what is our F net? We have Fx. It is in the direction of the object. So we have Fx. Then since the frictional force is opposing the motion, so we're going to have negative F or Fk. Then it's equals to MA. So what is Fx? F cos theta, and minus frictional force is the coefficient of kinetic friction multiplied by normal force. Then it's equals to MA. That is the formula. So what is F is 50, then cos 30 degrees, minus, we are looking for the coefficient of kinetic friction, and then the normal force, we got 54. And then we have 54, oh, not 54, 5,4, I mean, sorry. And then it's equals to the mass of the object, that is 2, the acceleration, they said is 20. And then now, 50 cos 30, this one is giving us 43,301. Then it's equal minus. We're taking 3 decimal places because this is not the final answer. So we don't have to round off to 2 decimal places. So this one, we have 5. This one is 5,4. Then the coefficient of kinetic friction. Then it's equals to 2 times 20. That is 40. So from here, we're going to take 43 to the other side. Then we'll be having negative 5,4. Then the coefficient of kinetic friction is equals to 40 minus 43. That is 3,301. So from here, it was negative. And then from here, we're going to divide by negative 5.4. Negative 5.4. And then coefficient of kinetic friction is equals to, so 3,301 divide 5.4 is equals to 0,61. So here we don't have the unit because the coefficient of the kinetic friction is the ratio of 2 forces. That's why it has no units.